Thank you very much. Dear participants, let me speak about our results which we received last time. Our results, we constructed the new methods for solving initial value problem for integro-differential equation of Volterra type. It is not difficult to show that initial value problem for ordinary differential equation and the initial value problem for integro-differential equation of Volterra type has some similarity. For example, if in the equation of Volterra integro-differential equation, the integral will be not participate. In this case, we receive the same problems, which the specialists studied many long time, beginning from the Newton. And it is not difficult to show that one of the first simple methods for solving this equation, specialists take as the Euler methods, because the Euler methods, explicit Euler methods, is very simple because all the mans want to use only Euler methods. But Euler himself to say about this method that this method has any negative properties. For example, in a general form, one can be say the local truncation error for explicit Euler method equal to. But himself, Euler says that for this some big value for n, this very small mistakings after summing can be received very big values. Euler proposed to use the second members in the Taylor expansion. It is very difficult way for the construction method, because here we by using the some results which have used in solving initial value problem for ordinary differential equation, we can by some modification to apply to solve initial value problem for Volterra integral differential equation. Here we used some intersection of the construction methods for solving ordinary differential equation and Volterra integral differential equation. For example, we can be take the Euler's methods, explicit or implicit methods. And one can be shown that the order for these methods, explicit and implicit methods, one and the same. In this case, arises some question about that which of these methods can be taken as beta. Usually, the specialists take the implicit methods as the beta, because I am sorry. Here written the trapezoidal methods. Here we have shown that the trapezoidal method can be received from the Euler methods, explicit and implicit method. In this case, arises some question about that how one can be compare these methods. And we show that Euler's method can be taken as a bilateral, because one of them if we will be less than exact values, others will be big. By using these properties, we have constructed the summing these values, we show that one can be received from these methods, trapezoidal methods. It is known that trapezoidal method is more exact than the Euler's methods. By this way, we show that and prove that in some times it will be better to use the summing some methods which will be better. By using this idea, we constructed more general methods, and by choosing the coefficients which participate in these methods, which written here, we constructed the new methods with the beta properties. Here written the linear multi-step methods. It is known. If gamma I equal to 0, in this case, from here we can be received the multi-step methods which fundamentally studied by Dahlquist. And Dahlquist shows that how one can be to relate the exactness of these methods with the values of coefficients alpha I and beta I. By choosing these coefficients, one can be constructed methods which have exactness which equal k plus 2. K in usually take as the order of the multi-step method, because if we see these methods, one can be take about that here written the finite difference equation with the order k. By taking into account that k here is stopped it, because Dahlquist used the new conception which called as the degree of this method. By this investigation, we receive that we must find some relation between of k and degree p. K is given because if we can find some relation for the p degree, in this case, by using value k, we can find the new methods. By taking this into account, Dahlquist proves that in this class methods, one can be constructed the stable methods with the degree p equal k plus 2. It is the maximal value. And if k is even, in this case, p box equal to k plus 1. By some modifications, these methods, we receive the new methods, multi-step methods, and apply it to solving initial value problem for Volterra differential equation, and prove that if we used the classical linear multi-step methods for solving this problem, in this case we can be constructed methods with the maximal value which equal k plus 2 or k plus 1, which depends from the even or odd of k. And by taking this theory, we constructed the new method with the new properties, and prove that in some times one can be proved constructed the new methods which will be more exact than the now. Formula 16, which written here, one can be taken as not linear multi-step method because here participate the hybrid paths. In general, this method can be called as a hybrid K-step method or multi-step method of hybrid types. It is known that hybrid methods has the more exact than the others, but in the application of this method arises question which related with the calculation of the values of the solution initial problems at the hybrid points. To find these values, it is very difficult because all the specialities say that one of the these properties for the hybrid methods can be taken is not beta. And we constructed the new methods which can be say as the predictor corrector methods. For the calculation, the values of the solution of our problems at the hybrid points. For example, we can be take the following. For example, method which written here is the hybrid methods. And for the calculation, these values, for example, yn plus 3 and others, to calculation these values very difficult. We constructed special methods for the calculation these values. The values of the solution of our problems at the hybrid points. And we show that by choosing step size, one can be constructed methods which in ordinary cases uses, for example, Simpson methods. If we change the step size, from that we can be receive any hybrid methods, but which written here is the second methods. It is the modification of the Simpson methods and which has the same degree. But in the solution concrete problem, we show that these methods in which we use the step size of the hybrid types gives good result than the others. For the compares these methods with the others, we here constructed bilateral methods. Bilateral methods, I think we have any information. For example, Chaplygin methods. It is very known Chaplygin methods, but Chaplygin methods is analytical methods. We constructed numerical bilateral methods and show that these methods can be taken as a beta because when we use ordinary numerical methods receive any results, but to say about these results, how many available this value, to say anything very difficult. And if we use the bilateral method, in this case, one can be say the exact values will be take between of these values. But by using this theory, we constructed bilateral methods and to compare the known methods and show that this method is very better than the others. And this theory we applied and demonstrated by the numerical results which written here. I finished the results which I can be presented for you. If we have any question, I am ready to answer. No, but I want notice that this theory is very interesting because by using the very simple methods, one can be receive the very good results. Please, if you have any question, I am ready. Nichols, Nichols.
Did you use any program for something?